All right, welcome to the third and final video for today's lecture, where we're going to be actually learning about the free body diagram. So typically, instead of writing out free body diagram, you'll see FBD written out instead. It's just the abbreviation for it. So with free body diagrams, we are going to be using them to help us figure out the forces we have in our given directions so we know which Newton's laws to apply. Like I said, we're going to be covering those next time. So don't worry about the actual results. We just want to focus on what we do now. So the textbook, this is its recommended system to go through and identify all the forces acting on the object. So what we did in the last video. 2, draw a coordinate system. This is going to be extremely important for forces. This is more important for forces than it was for kinematics and for any other topic we're going to be talking about in this class. You must draw a coordinate system for every question you do associated with a free body diagram. If you do not draw a coordinate system, you will automatically lose points. On exams, typically the questions are 20 or 25 points. You will lose a full point for not drawing a coordinate system. So let me make it clear. If you do not draw a coordinate system, you are in trouble. Draw the coordinate system. Do it. I know it's annoying, especially if you're using a standard coordinate system, but in a lot of cases, we're not. So draw the coordinate system. Personally, for number 3, I'm okay if you don't want to do it. So it says represent the object at a dot at the origin of the coordinate axis. I'm okay if we don't do this. In fact, what I like to do is I like to draw my coordinate system away from my object. I personally like to draw a box for all of my objects. All of my objects are boxes. And the reason I like to draw a box is it's a little bit easier to draw stuff on. And then I personally like to put my coordinate system elsewhere. The textbook, when it does its solutions for the examples in the text, it is going to have the object at the origin and it's going to be a point. So I'm okay if you don't want to do 3 exactly as it is. I'll show you in the next slide, because we're going to do an example, what I like to do. You can do what I do, you can do what the textbook does, you can do something different as long as you have a coordinate system. So once you do that, you're going to draw the vectors, again, roughly the correct distance and roughly the correct length in relationship to each other. The step 5, it says draw and label the net force. I am okay if you skip 5, because sometimes you go through a question and you don't know what the answer is going to be till the end. So I'm totally okay, and in fact I don't do it. I don't draw the net force vector. So we're just gonna, let's just cancel that one out. Let's not even look at that one, because right now what we want to focus on in this class is how do we know which direction the forces are? How do we know what the values of the forces are? How do we know which direction they point in? That is what we're focusing on, is that we'll go through and calculate the net force in a lot of questions. So part of the reason we're doing this is, 1, I don't want you guessing your net force. Because sometimes if you guess a net force and your calculation is wrong, you're going to think, oh, I messed up my calculation. When in fact, you could have just guessed the net force wrong. So I don't want you to guess net forces, and I don't want you to have to go back at the very end of your question and remember to draw this vector. So I'm never going to look for a net force vector. I'm not looking for it. The textbook will have it, but I don't care. Because again, we're focusing on the other forces in this class. So as we get into Newton's laws of motion, I'll come back to talking about free body diagrams and how they're drawn in more detail and how we can use them associated with Newton's laws of motion. But right now, we're just introducing the idea of it, and let's do an example of figuring it out. So here we want to identify the forces of on the object and identify the free body diagram for the object, which in this case is a cat sitting on a windowsill. This is not my cat. It's a freaking cute cat. Wish it was my cat. I really want a cat. But anyway, I want a cat. This is the cat I've chosen off of Google. In reality, I want to steal my cousin's cat. That's a whole different problem. So we need to think about the forces on this cat. I'm going to draw a line here. The cat is on Earth. The cat has gravity. The cat is, so let's just go down the list. The next thing on the list was a spring force. Most windowsills don't have springs, so I think we're good at ignoring that one. It doesn't tell us anything about a string or a rope, so we can ignore tension. The cat is sitting on something. That is going to indicate that we have a normal force. It's not falling downwards, so we don't have gravity associated with it. Or sorry, we have gravity. We don't have motion associated with it, so we don't have drag. Again, we can ignore the electric and magnetic forces. Our cat is sitting, so we can ignore the kinetic friction. And with static friction, we don't know enough information. So what we're going to do is we're going to say static friction, but we're going to put a question mark. We don't know enough information. If the cat's thinking about getting up and it starts moving a little bit, we probably have to consider static friction. But if it's just sitting there, we technically don't need static friction. So let's go through now and let's draw the free body diagram. So my cat is now a box. You could draw it as a point. You can draw a not very realistic looking cat. Draw a shape. I'm going to indicate that it is on a horizontal surface that corresponds to my windowsill. I now need to draw my forces. According to the definition of gravity, we said it always points straight down. So I'm going to draw my vector. It's going to start roughly in the middle. I'm going to have FG. I also need my normal force, which is perpendicular to my surface, so it needs to be 90 degrees. In this case, it's going to point straight up, in which now we have our two forces we know we for sure have. My free body diagram is not complete because I didn't draw a coordinate system. So I'll let me do that now. I'm going to make it fun. I'm going to say left is my x direction, my positive x direction. It doesn't matter in this case, but let's just say it is because we can. We want to get used to the idea that we can change and will need to change our coordinate system moving forward in this class. So we have drawn the forces we know we have. We've labeled them. And we've drawn our coordinate system. Now what I want to do is quickly tell you, I'm okay if you don't want to include these vector lines over your forces. I'm okay with that. And the reason I'm okay with it is you've indicated it's a vector by using an arrow representation of your particular force. So I'm okay if you don't want to draw that vector line over it. I'm going to be honest, I'm not going to draw it moving forward. But I have the key aspects on here. I have my coordinate system. I have the two forces I know I have. I don't really have enough information to figure out static friction. So in reality, what I'm going to do is, because I don't have enough information, I'm just going to ignore it. That way I don't draw it on my free body diagram wrong. All right, so that's going to wrap it up for today's lecture. Please make sure to take the lecture quiz if you haven't already, and if you have any questions, let me know.